तो चलिए बच्चों, let us start the class for ninth class chemistry. And in the last period we have studied about the various atoms. Today even we are going to start studying about the various atoms and their structures. So let us start with the 15th number element. That is what it is known as the phosphorus. We know that an element, atomic number, an element has got atomic mass number. The atomic number is represented as Z. The atomic mass number is represented as A. Z is equal to the number of protons, and A is equal to the number of protons plus number of neutrons. So Z is determined from the number of protons, my dear students, and A, that is atomic mass number, is determined by the number of neutrons. If we have any element X, then in the subscript we write Z, and in the superscript we write A. So this is the way by which we represent the element. So today we want to study about the phosphorus. Phosphorus has got, you can see that on your screen, that phosphorus has got 15 protons, so its atomic number Z is equal to 15. Phosphorus, if we add up their, phosphorus has got 16 neutrons. So if we add up the number of protons and number of neutrons, that is what it gives you the atomic mass number. Your atomic mass number here is number of protons plus number of neutrons. You can see that number of proton is 15 and the number of neutron is 16. My dear students, you can easily see that number of proton is 15 and number of neutron is 16. And that is why this total sum adds up to be 31. The 15 remains 15, and this is how we represent the phosphorus 15p31. This is how we represent the phosphorus. Now, my dear students, when we look at the number of electrons for a neutral phosphorus atom, if we have 15 protons, then it will have 15 electrons. So in the first shell, which is known as the K shell, my dear students, you can see that it has 2 electrons, 1 and 2. In the L shell, you can see that it has got 8 electrons, 1, 2, 3, 4, 5, 6, 7 and 8 electrons. And in the M shell, let us find out how many electrons are there. 1, 2, 3, 4 and 5. So we will write its electronic configuration. So for phosphorus, if we write the electronic configuration, we will write it as a 2, 8, 5, which says that in the K shell it has got 2 electron, in L shell it has got 8 electron, and its M shell it has got 5 electron. This is how we interpret, or this is how we understand the electronic configuration of phosphorus. Now, my dear students, we want to study about the new element. The name of this element is sulfur. So let us study about the next element that falls on the 16th number of element, and that is what it is known as the sulfur. As it is on the 16th element, it has got 16 proton and it has also got 16 neutron. So my dear students, this sulfur has got 16 proton and 16 neutron. Your Z is equal to number of proton. So that is equal to 16. So Z is equal to 16 for sulfur. The symbol of sulfur is S, my dear students. And then if you want to calculate the number of atomic mass number, that is the number of neutron plus number of proton. You can see that it has got 16 neutron. This is what it is written over here, and it has got 16 proton. So total, if we add up, it turns out to be 32. And that is why you can see here I have written sulfur 16 proton, so atomic number 16, 16 proton and 16 neutron, so atomic mass number is 16 plus 16. That is how we represent sulfur as 16 as 32. We write 16 atomic number Z as a subscript and atomic mass number 32A as a superscript. And this is how we represent the sulfur 16 as 32, my dear students. Now we know that a neutral atom has got equal number of protons and electrons. So you can see that in the first shell, sulfur has got 2 electrons. In the L shell, it has got 8 electrons, and in the M shell it has got 6 electron. Let us count 1, 2, 3, 4, 5 and 6. So this is how, my dear students, it is always, if you have the atomic number more than 2, then you can easily understand that in the K shell there are always 2 electrons present. If you have atomic number more than 10, then you can say that in L shell you will always have 8 electrons. So here you have atomic number 16. That means you can easily say that K shell will have 2 electrons and L shell will have 8 electrons. And as it is 16, so 2 plus 8, 10. Now the 6 electrons are left, and these left 6 electrons are filled into the M shell. And this is how we can write the electronic configuration for sulfur as 286. My dear students, please remember that this electronic configuration is related to its atomic number, and when you add this number of electrons, this number of electrons will always be equal to the atomic number of the element. So this is how, my dear students, we study about the structure of the uh, element named sulfur. Now we want to study the structure of the element whose name is chlorine. So let us study about the chlorine, my dear students. You can see I have chlorine drawn over here. In the chlorine, my dear students, the atomic number is 17. So it falls on the 17 number, and it has 17 proton. But chlorine has got 18 neutrons, and that is why the atomic number Z for chlorine is equal to number of proton, and that is 17. So Z is equal to 17. If you look into the atomic mass number A, which is equal to the number of proton plus number of neutron, number of proton here is 17 and the number of neutron is 18, my dear students, and that is why we write it as 35. And this is how we understand that. You can see here, even I have represented the Z and A. This is your A. Your A is equal to 17 plus 18, and this is your Z, which is known as the atomic number, which is 17. So your Z and A is represented as ZCl35. So 17Cl35, my dear students. You can see that the atomic number is 17, and that is why in K shell it has got 2 electron, in L shell it has got 8 electron. So 2 plus 8, 10. So 17 minus 10 is equal to 7. So its M shell will have 7 electrons. And let us count the number of electrons present in the M shell. 1, 2, 3, 4, 5, 6 and 7. And this is how, my dear students, we can easily understand the structure of our chlorine atom. In chlorine atom, in the nucleus, we have 17 proton and 18 neutron. And around the nucleus, in K shell, there are 2 electrons. In L shell, there are 8 electrons. And in M shell, there are 7 electrons around the nucleus. And this is how, my dear students, we study about the structure of our chlorine atom. Now let's look to the next element, and the 18th number element is our argon. So my dear students, there are total 18 electron and 18 proton must be present into the argon. So you can see that in the nucleus of argon we have 18 proton. In the nucleus of argon we have 22 neutron, and around the nucleus, if we can count, we will find that there are total 18 electrons. You can see 1, 2, so there are 2 in K shell, then 1, 2, 3, 4, 5, 6, 7 and 8, 8 into the L shell, and then again 1, 2, 3, 4, 5, 6, 7 and 8 electrons again present into the M shell. So that is why we can write the electronic configuration of argon as 2, 8, 8, my dear students. We have studied that we can fill maximum 8 electrons into the shell. So you can see that here M shell has also been completely filled, my dear students, and no more electron now can go into the M shell. Now if we look into the nucleus of our argon, we can see that it has got 18 protons. So we can write Z is equal to 18. For our argon, we can write Z is equal to 18. You can see that I have written Z is equal to 18 and Z is equal to the number of proton, that is 18. And if you need to calculate the uh, atomic mass number, which is A, which is the sum of the number of neutrons plus number of protons. So number of neutron are 22 and the number of protons are 18, and when we add 18 plus 22 we get 40, my dear students. So we can represent our argon as 18Ar40, and the electronic configuration of argon is 288. My dear students, you can see that all the shells, K shell has been completely filled with 2 electron, L shell is completely filled with 8 electron, and M shell is completely filled with 8 electron. And this is how, my dear students, we can say that all the shells, whether they are K shell, L shell or M shell, all these shells are completely filled by the electrons, and that is why this argon is known as the inert gas, or it is the noble gas. It does not react because all its shells are completely filled, so it does not require any electron to be filled in the shell, or it does not want to give out any electron, and this is why this argon is a noble gas, or inert gas. Now, my dear students, we want to study about the next element, and that element has got its name potassium. So let us study about the new element. The name of this element is potassium. Potassium falls on the 19th number, so it has got 19 proton and 19 electrons around it, and it has got 20 neutron, my dear students. Now you can see that this potassium has got 2 electrons in its K shell, so we write 2 for K, then 8 electrons, 1, 2, 3, 4, 5, 6, 7 and 8 electrons in its L shell. Then when we look at the M shell, 1, 2, 3, 4, 5, 6, 7, 8. So L shell has also been complete, M shell has also been completely filled, and that is why the atomic number is 19. So 2 plus 8, 10 plus 8, 18, but still one electron remains, and then this new electron, you can see that the new electron goes into the new shell, and the new shell is your next shell after M, which we call it as an N shell. So the electronic configuration for potassium, my dear students, we write it as a 2, 8, 8, 1. So this is the electronic configuration of potassium, my dear students, and you can see that in the nucleus of potassium we have 19 proton, 20 neutron, and there are 19 electrons around the nucleus of our potassium. Now, my dear students, if we want to find out the atomic number Z, we know that the atomic number Z is equal to number of protons, and that is why we can write that for potassium Z is equal to 19. And if we want to calculate the number of or atomic mass number, we know that atomic mass number is equal to number of protons plus number of neutrons. So here, my dear students, we have 19 protons and 20 neutrons. So that sum up, if we sum up, we will get 39. So atomic mass number is 39 and atomic number is 19, and that is why we write it as a 19 potassium K 39. We are all aware that we write the atomic number as a subscript, and we write atomic mass number as a superscript for explaining or for expressing any element. Now we want to study the element which falls on uh, which is actually on 20th number. The name of this element is calcium, and that is what we are going to study about, my dear students. You can see that we have an element here. The name of this element is calcium, and you can see here the calcium in front of your screen, my dear students. Calcium falls on 20th number, so it has got 20 proton and 20 neutron. Uh, and as the total number of proton is 20, it must have 20 electrons. So 2 electron in K shell, 1, 2, 8 electron in N shell. You can see 1, 2, 3, 4, 5, 6, 7 and 8. So total 8 electron in L shell. Then 8 electron in M shell, 1, 2, 3, 4, 5, 6, 7, 8. 8 electron in M shell. And my dear student, you can see that there are 2 electrons in the outermost shell, which is known as which is actually your M shell. You can see that. So here in N shell, you have 2 electron, 1 and 2. And this is how you can represent the electronic configuration. For calcium, you write it as a 2, comma 8, comma 8, comma 2. If you add them up, 2 plus 8, that is 10. 10 plus 8, that is 18, and 18 plus 2, that is 20. So that is equal to your atomic number 20, my dear students. And when you look at the number of, so when you want to determine the atomic number, my dear students, you just take the proton. So your Z, which is atomic number, is equal to number of proton, which is equal to 20, and atomic mass number A is equal to the number of neutrons, number of protons plus number of neutrons. You can see that number of proton is 20, so you write 20. Number of neutron is 20, so you write 20. And thus, my dear students, the atomic mass number is 40 for our calcium. So we represent 20 calcium 40. So this is how, my dear students, we study the first 20 elements of, and these first 20 elements, their structures, how their nucleus are made up of, how many protons are present in their nucleus, how many neutrons are present in their nucleus, how electrons are distributed around the nucleus, in what shell, what number of electrons are present, what is the atomic number of the element, and what is the atomic mass number of the element. That is what all we have studied in detail. My dear students, I want to bring something to your notice, that please note that if you look into the argon, the atomic mass number of argon is 40. You can see that we have written 18 argon 40. Please remember that we have written 18 argon 40. We have written 18 argon 40. So its atomic mass number is 40. Now if you look into the calcium, my dear students, you can see that even for calcium we write 20 calcium 40. So please remember that the atomic mass number of both argon and calcium are same, my dear students. And this is what it happens because of the number of neutrons which varies. You can see that our calcium has got 20 neutrons and our argon has got 22 neutrons, and that is why their atomic mass number become same. So please remember that the atomic mass number of our calcium as well as the atomic mass number of argon are same. Please remember the atomic mass number of calcium and the atomic mass number of argon are same. So now let's move and study more questions and solve them. What is the name given to electron distribution in chemistry? So my dear students, electron distribution in various shells or energy levels is called electronic configuration. What information can we obtain from the electronic configuration, my dear students? So from the electronic configuration, we can determine outermost shell. Please remember, from the electronic configuration, we can determine the outermost shell, which is also known as the valence shell. We can determine the atomic number and we can determine valency. Please remember, my dear students, that from the electronic configuration, we can come to know about the valence shell, or we can come to know about the valence electron, or we can come to know about the outermost shell. We can even come to know about the valency of the atom, and we can even, when we calculate the number of electron, we get atomic number, which is known as Z. So if you have a neutral atom, like if you think about chlorine, and its electronic configuration is, let's say its electronic configuration is 287, then we can say that Z is equal to our atomic number. Z for chlorine is equal to this electronic configuration, we just add it up, 2 plus 8 plus 7, and that is equal to 17. So the atomic number of chlorine is 17 because the number of electrons present into chlorine is 70. But remember, to identify the atomic number, the species or the atom that we take should not have any charge. It must be neutral. So my dear students, from the electronic configuration, We can come to know about the valence shell. We can come to know about the outermost shell. Actually, outermost shell is called the valence shell. We can come to know about the atomic number, and we can come to know about the valency. Now, next question. Define outermost shell or valence electron. Then the next definition we will study about is the atomic number. Then we'll study about the atomic mass number, and then we'll study about the valency. So let's look into one by one. First, let's have a look to the outermost shell, which is also known as the valence shell. The shell or the energy level in which last filled electron enters is called the outermost shell, or it is called the valence shell. For magnesium, the atomic number for magnesium is Z is equal to 12. So its electronic configuration is 2 plus 8, 10. So 2 are left. So it is 2, 8, 2. So here you can see that in K shell it has got 2 electron, in L shell it has got 8 electron, and in M shell it has got 2 electron. So the last filled electron goes into the M shell, and that is why M is the valence shell for magnesium. Now what is the definition for the valence electron? So the electrons present in the outermost shell of an atom is called valence electron. So for magnesium, you can see that the valence shell is M, and in M we have 2 electrons present, my dear students. In M we have 2 electrons present. You can see that in M shell we have 2 electrons present, and that is why these 2 electrons are called the valence electrons for magnesium. So this is how, my dear students, we can study. Now if we look into some other examples, if we think about sodium, then the electronic configuration of sodium is 281. So if we look into the various shell, we have K, L and M shell. So M shell is the valence shell, and it has got 1 electron, and that is why sodium has got 1 valence electron. If we look into the phosphorus, my dear students, if we look into the phosphorus, its electronic configuration, the electronic configuration of phosphorus is 285. So again you have here K, L and M. So M shell is the valence shell, and valence electrons are 5. If you look into the oxygen, my dear students, the electronic configuration of oxygen is 2, 6. So it has 2 shell K and L shell, and L shell is the outermost shell, and it has got 6 valence electrons. If you look into the calcium, my dear students, the electronic configuration of calcium is 2, 8, 8, 2, and it's K. The shells filled are K, L, M, and N shell. So this outermost shell, the last electron goes into the N shell. So N shell is the valence shell, and there are 2 electrons present into the valence shell N, and that is why we can say that calcium has got 2 valence electrons. So this is how, my dear students, we determine the number of valence electron, and we determine the valence shell. Now let's look into the new definition, which is known as the atomic number. Total number of protons present in the nucleus of an atom are called its atomic number. Please remember that the total number of protons present in the nucleus of an atom is called its atomic number. So atomic number is denoted by the symbol Z. And magnesium has got 2 plus 8 plus 2, that is total 12 atomic number. Atomic number of magnesium is 12. So for a neutral atom, atomic number Z can also be calculated from its electronic configuration. So if you, for a neutral atom, the number of protons and number of electrons are same, and that is why by the adding the number of number of protons into the neutral atom, we also get atomic number. And for magnesium, the atomic number is 12. So same way, if you think about sodium, and if its electronic configuration is 281, the atomic number is 2 plus 8, 10 plus 1, 11. Same way for oxygen, if its electronic configuration is 2, 6, the atomic number would be 2 plus 6, that is 8. So this is how, my dear students, we understand how to calculate the atomic number. Please remember that Z is equal to the number of protons present into the nucleus. But for a neutral atom, the number of protons present into the nucleus and number of electrons present outside are same. And that is why from the electronic configuration even, we can calculate the atomic number. In neutral atom, number of protons and number of electrons are same. Please remember that in neutral atom, the number of protons and number of electrons are same, and that is how my dear students, we understand about the, and that is why Z is equal to proton is equal to number of electron for a neutral atom. For a neutral atom, we can write that Z is equal to number of protons or number of electrons. Now, my dear students, we want to study about the atomic mass number. So let us study and let us read the definition of the atomic mass number. The sum of the total number of protons and neutrons present in the nucleus of an atom is called atomic mass number. We have seen that atomic mass number is denoted by A, and my dear students, the atomic mass number A is equal to number of protons plus number of neutrons. Therefore, A is equal to P plus N. But now remember that using this equation, we can write that number of neutrons is equal to A minus P. That is the atomic mass number minus P. But my dear students, we know that atomic mass number P, atomic number is represented by the number of protons. So we know that Z is equal to P, and therefore instead of P we can write Z, and that is why we can say that number of neutrons is equal to A minus Z. Therefore, number of neutrons in a nucleus, therefore number of neutrons in the nucleus of an atom is equal to atomic mass number of an atom minus atomic number of an atom. Please remember atomic number of an atom. Please remember that number of neutron is equal to A minus Z. Your A is atomic mass number and Z is atomic number, and that is why we can say that number of neutrons in the nucleus of an atom is equal to atomic mass number A minus atomic number Z. This is very interesting to study. Please learn these equations. So atomic mass number, the number of nucleons. Now my dear students, we know that these protons and neutrons are collectively known as nucleons. These protons and neutrons are collectively known as nucleons. So we can write the another definition also for our atomic mass number, that number of nucleons present in the nucleus of an atom is called atomic mass number. Please remember that number of nucleons, that is the number of protons plus neutrons. So we can even say that atomic mass number is the number of nucleons present in the nucleus of an atom is called atomic mass number. My dear students, I would like to make you remember this definition also. So I am repeating once again. The another definition of atomic mass number is the number of nucleons present in the nucleus of an atom is also called the atomic mass number. Now, my dear students, we want to study about the valency. So, combining capacity of an atom or of an element is called its valency of an element. Please remember that combining capacity of an atom of an element is called valency. You can simply remember that valency is nothing but combining capacity. Please remember that valency is the combining capacity of an atom of an element. Now, my dear students, we want to study about the how to write the notation or expression of an atom. How should we write the notation or expression for an atom? We have already studied it, but just we are writing it in the form of the question answers. So, in the notation for an atom, the atomic number and atomic number and mass number and the symbol of an element are to be written as, you can see that we just in the middle part we write the symbol of the element, in the subscript we write the atomic number, and in the superscript we write the atomic mass number. So for example, nitrogen is written as 7n14. So 7 is the atomic number of nitrogen and 14 is the atomic mass number of nitrogen. How to calculate the valency of an element? So my dear students, how can we calculate the valency of an element? Let us study it. Valency of an element can be determined by knowing the valence electron. So valency depends upon the valence electrons, my dear students. We have just seen that the total number of electrons present into the outermost shell are known as the valence electron. So the outermost shell of an atom, that is valence shell of an atom, can accommodate maximum 8 electrons, my dear students. Please remember that the valence shell or the outermost shell can accommodate maximum 8 electrons. So depending upon the valence electron or depending upon the number of valence electrons, there are two formulas to calculate valency. So let us understand or let us study the formulas to calculate the valency. If number of valence electron is 1 to 4, please remember that if the number of valence electron is 1 or 2 or 3 or 4, then we will use this formula that valency is equal to number of valence electron. If the number of valence electron is either 1 or number of valence electron is 2 or number of valence electron is 3 or number of valence electron is 4, their valency is equal to number of valence electron. That means if the number of valence electron is 1, the valency is 1. If the number of valence electron is 2, the valency is 2. If the number of valence electron is 3, the valency is 3. If the number of valence electron is 4, the valency is 4. Let us study with the example. Sodium has got electronic configuration 281. So 1 is the outermost shell, and in the outermost shell we have 1 electron, and that is why the valency of sodium is 1. If we look into the calcium, the electronic configuration is 2882. So the outermost shell has got 2 electrons. So there are 2 valence electrons, and that is why the valency of calcium is 2. If we look into the aluminium, the uh, the uh, the electronic configuration of aluminum is 283. So you can see that in the outermost shell we have 3 electrons, and that is why, my dear students, the valency or the total and that is why the valency of aluminum is 3. My dear students, if you look into the carbon, the electronic configuration is 2 4, and that is why it has got 4 electrons in the valence shell, and that is why valency of carbon is equal to 4, and carbon is called tetravalent element. Now what happens if the number of valence electron is more than 4? So let us study about it, my dear students, that the number of valence electron is more than 4, then the valency is equal to number of valence electron minus 8. Please remember to calculate the valency for any element which is having the number of valence electron more than 4. We calculate the valency is equal to number of valence electron minus 8. For example, in chlorine, if we have the electronic configuration 287, you can see that chlorine has got 7 valence electron, and that is why valency of chlorine is 7 minus 8, which is minus 1. Please remember, my dear students, the valency is called 1, but this minus sign represents that chlorine will make negative ion or anion. Same way, when we look into the oxygen, oxygen has got electronic configuration 2,6. From this, my dear students, we can easily understand that oxygen has got 6 valence electron, which is more than 4, and that is why we can calculate the valency of oxygen as 6 minus 8, which is minus 2. So the valency of oxygen is 2, my dear students, but minus 2 or this minus sign represent that our oxygen will make negative ion, and generally our oxygen make O minus 2 ion, or our chlorine will make Cl minus 1 ion. Same way, my dear students, if we look into the nitrogen, the electronic configuration of nitrogen is 2 5. So nitrogen has got 5 valence electron, and that is why the valency of nitrogen is equal to 5 minus 8. That means it is minus 3. Here minus sign represents that nitrogen will make anion, that is having negative charge, that is N minus 3, which is known as the nitride ion. We have already seen it. And my dear students, the valency of nitrogen is 3. So we can say that the valency of nitrogen is 3, but from the minus sign we can come to know that nitrogen will make minus 3 ions. And same way, my dear students, if we look into the if we look into the argon, the electronic configuration is 288. So argon has got 8 valence electrons, so the valency is 8 minus 8, which is 0. That means argon will not make any ions, or argon will not combine with any other elements. The combining capacity of argon is 0, and that is why the valency of argon is 0, and that is why argon is called the inert gas, or noble gas. Please remember that the helium is the only element which is having its outermost number of electron is 2, but it is inert gas. It is inert gas, my dear students, or it is noble gas. Helium is a noble gas, and that is why the valency of helium, please remember that valency of helium is 0. Please remember, please remember, my dear students, that helium has got valence electron is equal to 2, but its valency is equal to 0. Please remember, the valency of helium is considered to be 0 because helium is a noble gas or inert gas. Now we'll move forward and we'll study which elements have their valency 0 and why. So please understand, my dear students, that noble gases or inert gases, for example, helium, neon, argon, krypton, xenon and radon, etc. have their valency 0. As they have completely filled outermost shell or valence shell, for example, if you look into the neon, you can see that its electronic configuration is 2, 8. So it has got 8 valence electron. My dear students, you can see that our neon has got 8 valence electron, and that is why its valency is 8 minus 8, that is 0. Same way, if you look into the argon, the electronic configuration argon is 2, 8, 8. So it has got 8 valence electron, and that is why the valency is 8 minus 8, that is equal to 0. Remember, my dear students, that helium has the electronic configuration 2. So it has got 2 valence electron, which has 2 electrons in its outermost shell, but outermost shell is completely filled. So helium, so the